I have the absolute value of 3x plus 2 equaling 17. So, um, an absolute value is a grouping symbol, yes, but it's not like a parenthesis. Parentheses is kind of, if they're there and you don't have any kind of number, it has to be distributed as it's being multiplied on the outside. They just drop out. Absolute values don't just drop out if there's nothing on the outside of them. They are a grouping symbol that have specific meaning behind them. And the meaning is an absolute value symbol takes whatever's inside and makes it a positive value, because what you're actually doing is describing a distance from the 0 point on a number line. That's really what all it is. That's what an absolute value represents. So, and distances are always reported as being positive, because what's a negative distance? I mean, you can have something that describes something with a negative number as being, its position, but its position and distance are related, but not the same thing. So one thing I have to keep in mind as I deal with an equation that involves an absolute value is I have to know what an absolute value does. And so I have the absolute value of 3x plus 2 equaling 17, which means I have the absolute value of something being 17, or I'm taking something, doing its absolute value, and getting a positive 17. Well, that something I'm taking the absolute value of can be only one of two things. It's either going to be 17 or it's going to be negative 17. And that's how I get rid of the absolute value. I have to split it into two separate equations. And that's a step that a lot of students skip doing. They'll just get rid of the absolute value symbol like a parenthesis, do the left-hand equation only, get an answer, and they think that's it, and then they only did half the problem. I mean, you're doing the same thing through here on out, as far as, algebraic manipulation, but, what you end up on the right-hand side each time is going to be different, because in each one of these I'm going to subtract 2 from each side. On the left-hand equation I get 3x equals 15. On the right-hand equation I get 3x equals negative 19. And then I'm going to have divide both sides by 3 on both equations. And on the left I get x equals 5, or I get x equals negative 19 thirds. Or you could say like negative 6.3 repeating, whatever you need to do. But, watch the rounding. We're going to talk about rounding issues as we go through this course, and how we avoid over rounding on a problem. It becomes an issue. We start especially dealing with exponential functions in chapter 3. But now, anytime you solve an equation, you really should check your answers to see if they work. And in both cases here, when I plug the number in, it works. I start making it a point to do so with absolute value equations, because absolute value equations are kind of one of the first equations that students in the high school level deal with, where you have the potential for what they call extraneous solutions. And extraneous solutions come about because you're doing everything algebraically correct, but because of an assumption you had to make early in the problem or something along those lines, you might be creating a circumstance that just can't happen with this sort of setup, and as a result the answer you get just doesn't make sense with respect to the rest of the problem. So it's situations in part B where that happens most often. The reason being is this: we have the absolute value of 3x plus 2 equaling x plus 8. Now I don't know what x is, so I don't really know if x plus 8 is positive or negative. I don't even know if x is positive or negative. The fact of the matter is, there could be some values of x that makes x plus 8 positive and some values of x that make x plus 8 negative, obviously. And do any of them work in conjunction with the absolute value of the 3x plus 2 on the left, so that I can have these two things be equal? Well, when I go through the process, I'm going to go through the exact same process I did in part A. I'm going to say, well, 3x plus 2 could either equal x plus 8, or it could be the opposite of x plus 8. The thing is, I'm working under a premise that x plus 8 can only possibly be positive. And that's where I add the potential for extraneous solutions, because I'm making an assumption about an unknown value. Just to get the equation to carry through. And so what will happen is if In a situation like this, if I end up, if by doing so I create a circumstance that cannot simply happen, that means that when I get an answer and go to plug it into the original equation, it just doesn't work. It's considered to be extraneous, so we just throw it away. So, like we did before, now here I got x's to get on, I try to get those on the same side. I had to distribute a negative on the right equation, so I'm going to do that first. On the right hand equation, I'm distributing that negative, and so it becomes negative x minus 8. In both equations, what I did here, well, on the left equation, what I did is subtracted x from both sides, but I also subtracted 2 from both sides. On the right equation, I added x to both sides and subtracted 2 from both sides. So I actually, did a couple of operations there at once for the interest of saving space. So I get 2x equals 6, or 4x equals negative 10, which means that once I divide 2 on both sides of the left equation, I get x equals 3, or 4 on both sides of the second equation, I get x equals negative 2.5. Now here I try them out. They both work. So there's no extraneous solution here, but make sure that, when you deal with absolute value equations, it's now the time where you take that check your work step in an algebra problem from being something that's recommended to something that becomes mandatory. Because the moment that you fail to do that, the moment that you don't check your solutions, that's whenever an extraneous solution has come up and you find out that one of those answers should have been eliminated.